Now, I want to start off the heart section by doing a bit of a drawing. Normally I do this on the chalkboard and we kind of work through it, but I think this is the best approach when we're in a remote setting. Also, it'll be nice for review. If I draw a totally accurate, anatomically correct heart, it's going to look something like this, with our interventricular septum dividing the left and right halves of the heart, and the fibrocartilage skeleton of the heart creating a division between the atria on top and the ventricles on bottom. So I will do the right atrium here, left atrium there, right ventricle here, left ventricle there. Now I think it's helpful to start off just looking at the kind of diagrammatic anatomy of the heart, as opposed to getting lost in the details of is the left side thicker or thinner, or what are the tuberculae carni. Let's just look at how blood moves through this and the main players, the valves, in determining how blood moves through it. So in order for blood to move through our heart, we have to have some openings. So I'm going to draw, again, totally anatomically accurate, right? If you've looked at the heart already. I'm going to draw just some openings in my diagram that is going to allow blood to go in and out of the ventricles and between the ventricles and the atria. When I do that, I can then add some vessels. And valves, which are these little flappy guys I'm drawing in there. Okay, so if we want to start on the systemic venous side, so I'm just going to shorthand drawing all the bodies, all the vessels in the body, and just draw a very anatomically accurate body down there. Now this does not include the lungs. For the lungs, the pulmonary circuit, I am going to draw a trachea, which splits into two bronchi and goes into two lungs. So this is my pulmonary circuit up top and my systemic circuit up bottom, down bottom, up bottom. Now, what we have here, if we start on the systemic side, is that we are going to have venous blood going into the right atrium. So this is venous, and I know it's venous because it's going back to the heart. That's what makes it venous, not that it's blue. The blue, however, tells me that it is low in oxygen, but high in CO2. This will also be low in pressure because it's been a long time since it went through the pump of the heart. I can then, so this is actually going in through two vessels, the superior vena cava and the inferior vena cava. Again, don't worry about the anatomy, but if you're reviewing, that's helpful to pull back in. So it goes through the inferior and superior vena cava into the right atrium. This is coming from the body, systemic blood, so low oxygen, high CO2. It then goes into the right atrium. And from the right atrium, the only place it can go is down into the right ventricle. So whatever side of the heart you go in on, you stay on that side. You don't cross, at least in an adult. For kids, it's weird. And then the right ventricle is going to contract. And when it does, it's going to push closed that AV valve. And we have to have that AV valve, otherwise, when the right ventricle contracts, that blood will just go back into the venous circuit. So the first valve that we run across, the number 1 right there, go over here, is my right atrioventricular valve, also known as the tricuspid valve. Now, I am abbreviating AV and RA and all this. On any lab or anatomy-based stuff, I want you to write them out. On an essay, totally fine abbreviating, but anything where I'm asking you to specifically identify something, it needs to be written out. So that blood goes through a right atrioventricular valve into the right ventricle, and then the ventricle starts to contract. This happens at the same time the left ventricle contracts, but we're not talking about that one right now, so I'm going to ignore it. So that blood is now getting pressurized in the right ventricle, but it can't go, sorry, my notifications are on, it can't go out yet. So that blood is going to have to force its way out through our second set of valves here. Those are my pulmonary semilunar valves. or valve. So that blood is going to get forced out of those, and it then goes into my pulmonary trunk. Again, a lot of abbreviations so I don't overwhelm this page with writing. And that blood is going to go out. I'm going to just start hopping over this because it's not like those vessels meet. They just go past each other. And this is now arterial blood because it's exiting and going away from the heart. It is still low in oxygen and high in CO2, but because it's arterial, I know this is also a high pressure line, relatively speaking, to the venous side. Now, in the lungs, their whole job is to add O2 and remove CO2 from blood, and then ventilate that air with the atmosphere. So basically, we bring in fresh air into our lungs, we swap that fresh oxygen into the blood, we get the CO2 that was in the pulmonary blood, and then we push that stale air now back out in the environment, bringing new fresh air in. All we need to know about the lungs at this point. Now, because we added O2, that changed the color of blood because of how hemoglobin works to bright red. And that bright red blood is going to go back to the left side of the heart. And it does so by entering what we call our pulmonary veins. These are veins, so they are low in pressure. However, they are coming from the lungs, so they are high in oxygen and low in carbon dioxide. Now, that venous blood goes back into the heart, and it's going to go into the left atrium, which is then going to pass through the left atrioventricular valve, which is number 3. Left atrioventricular valve, also known as the mitral valve and the bicuspid. Again, I want you to know all 3 of those names. Now that oxygenated blood flows into the left ventricle where it fills the ventricle. This is between beats. And when the heart does beat, that blood tries to go back out the AV valve, but the AV valve gets pushed closed. And our chordae tendineae make sure it doesn't blow back open. So instead, that blood is going to go out the valve that does let it exit. It goes out the aortic semilunar valve and into the aorta. So that will be number 4. Now, I am writing out semilunar valve, but you don't have to. You can just write aortic valve or pulmonary valve, and the semilunar is implied in that. And that blood will then go into the aorta and go out to the body. Wherever in the body it's needed, anything that is not in the lungs exchanging gas. And I say exchanging gas because even the lungs have tissue that need to get supplied with their own oxygenated blood. So there actually is a systemic circulatory path to the lungs. We'll talk about it more in the vessels week next week. But we just know that the tissue in the lungs, the muscle and the cartilage, that still needs to get oxygenated blood. Even though the lungs are getting oxygen from the environment, they aren't really good at oxygenating their tissues. We need to have systemic blood for that. Okay. So because this blood was exiting the heart, it is arterial. Specifically, it's going out on the aorta. Because it's arterial blood, I know it's high in pressure, because that's why it's moving away from the heart. And because it's red, I know this is high in oxygen and low in carbon dioxide. Again, I know that I have said this a few times, but I really want to emphasize the red tells us that it is oxygenated. The artery and vein tell us the direction that it moves. So an artery is always exiting the heart, a vein is always returning to the heart. Red means oxygenated, blue means deoxygenated. When you do see it later on, purple is a mixture of both oxygenated and deoxygenated, and it shows up in special circuits. All right, this is a good primer for the heart that will work well with the lab and the lecture.